Zeros, are they significant or not? Well, the answer is that it depends. There are a few rules that tell us when we can consider a zero to be significant and when we can't. Let's go through them right now. Here's the first one. Zeros sandwiched between non-zero digits are always significant. What does this mean? Well, it means, let's say we have a number like 3091. Okay? We know from what we've already learned that the 3, the 9, and the 1 are all significant. And since the 0 is sandwiched between them, it too is significant. So there are 4 significant figures in this number. How about a number like 82,024? Again, 8, 2, 2, and 4 are all significant because they're non-zero numbers, and since the 0 is sandwiched between them, it is also significant. We have 5 total significant figures in this number. Now, it doesn't just have to be one 0, and it doesn't have to be in just one place. Okay, so we can have a number like 109,003. Again, 1, 9, and 3 are significant, and since these zeros are sandwiched between them, they are all significant too, so there are a total of 6. Number of zeros doesn't matter. Number of groups of zeros doesn't matter. And the other thing that doesn't matter is decimal points. Okay, so we can have 5.00603 or something like that. And just as long as we have these significant figures and the zeros are in between them, they're all going to be significant. This number here is going to have 6 significant figures. So that's our first rule. Zeros sandwiched between non-zero digits are always significant. Let's look at the next one. This says here that zeros that come before all non-zero digits are never significant. Okay? So an example of this would be 0.000491. All these zeros here come before the non-zero digits. And obviously when I say before, I mean to the left of. So these guys are significant. All these zeros come before them. We don't even have to worry about them. 3 significant figures total in this number. Another example could be 0.0132. These guys are all significant, but the zeros coming before them or to the left, they don't matter. They're not significant. Again, only 3. As we've seen with significant figures problems before, it doesn't matter how many you have, right? So it can be 0.00000000062. And again, these guys are significant, but none of the zeros that come before them or to the left are significant. We don't have to worry about any of them, and this number only has 2 significant digits, the 6 and the 2. Okay? So that was what happens when we have zeros that come before or to the left of a number. Zeros that come after or to the right of non-zero digits get a little bit trickier. Here are 3 examples. All of them have a different number of significant figures. Or I should say, we determine the significant figures in them differently. 83,000, which looks identical, except I'm going to put a decimal place at the end of that. And then let's say 83.000. So they all have 1, 8, 1, 3, and 3 zeros. But we apply different rules to each of them for the significant figures. If we have zeros that come after non-zero numbers, and there is no decimal place in that number, the zeros are not significant. 8 and 3, which gives us 2 total here. The other 3 zeros are not significant. Now we always ask our question, is there a decimal point in this number? Okay, here there wasn't, so the zeros were insignificant. Ask it again. 83,000, but with a decimal point at the end, means that the zeros that come to the right of the non-zero digits are significant. Okay, so that means that all 5 of these are going to be significant, and our number has 5 significant figures. The only difference is this decimal point right here. It's here, it's not here. Zeros that come to the right of non-zero figures are only significant if there is a decimal point. 83.000. Here are zeros coming to the right. We ask our question, is there a decimal point in the number? Yes, there is. So in this case, all three of these guys after the decimal point are significant. Again, 5 significant figures in this number. Okay? Let's look at a couple more examples of this. Okay, let's say we have 4,532,100. There's some zeros to the right of these non-zero digits, so we ask ourselves, is there a decimal place in the number? No, there's not. And since there's not, it means that these zeros to the right of the non-zero digits are not significant. 1, 2, 3, 4, 5 is the correct number of significant figures here. Let's look at 789.000. Again, zeros to the right of non-zero digits. Is there a decimal place? There is, which means that these right-hand zeros become significant. 6 total significant figures here. Let's look at 90,000. 90,000, significant figure, 1, 2, 3, 4 zeros to the right, but there is no decimal point in this number. So that means that none of these zeros are significant, and there is only one significant figure here. 200 with a decimal place after it. Significant, zeros to the right of it, there is a decimal point, so all three of them, including the zeros, are going to be significant. Lastly, let's do 50.000. Significant, zeros to the right, and since there is a decimal point, all of these zeros are significant, so we have 5 total significant figures here. Okay, so it all boils down to, if there are zeros coming to the right of non-zero digit, it all boils down to, is there a decimal point? If there's a decimal point in the number, the zeros to the right are significant. If there is no decimal point in the number, the zeros to the right are not significant. I think the best way to learn this stuff is to go through a whole bunch of practice problems. All right, see a whole bunch of examples. That's what we're going to do right now. Now, if you've already got this down, we go through a couple of examples, just turn it off, move on to the next video. There's no need to watch me do all of these. If you're having trouble though, I think that we'll do enough problems that by the time this is over, you'll have a really, really good sense of when zeros are significant and when they're not.